Okay, so let's continue our topic number 1. So first, last time we discussed what is data, what is information, what are the features of data, good information, and those things. So let's continue that discussion, and then we'll move on to the introduction to computer. Okay, so that is the idea here. Okay, right. So last time we discussed what is data. Data is any property of a entity. So we discussed that data is a conceptual thing. Though entity can be conceptual, entity can be living human, or entity can be non-living human, but data is always conceptual. Okay, so that is the first thing you have to understand. So you must be able to differentiate between data and entity. Okay, so then we moved on to, of course, we categorized the entities into 3 types: living physical, non-living physical, and conceptual entities like order. Order is a entity, whereas order date is a data. Okay. A payment is an entity, whereas payment amount is a data. Employee is an entity, whereas employee name is a data. Okay. So then we discuss data is good, but information is better. Right. So data is good, like daily rainfall, but the average rainfall is better. Your marks data, it is good, but your Z-score is better for decision making. So Z-score is the information. Okay. So individual item amounts, unit prices and quantities, they are good, but what everyone is interested is the final bill amount. That is the information. Okay. So therefore data is good, but information is better. Okay. So that also we discuss. And also we discuss the 2 type of usages of information. The personal usages, like your address book, your personal income management, and so on. So then we discuss the business usages, like billing, invoices, payments, bank details, right? Salary details. So those are official or business related things. So we use information for daily personal things. We use information for official or business things. Okay. Right. So we discuss some typical usages like predictions, planning, right? Policy making, right? So then we discuss about what are the features of good information. Right. What are the features of good information? Effective means does the work. Accuracy. So if the data is or the information is not accurate, no one is interested in your information. Timeliness, we need the information when we need it. Relevance, what we need is the relevant information. We don't need unnecessary details. Economical, we must be able to get that information with reasonable cost. We must be able to rely on the information. It must be complete, not half of the part of the information. It must be flexible so that we can look at it in different ways, right? Tabular way, graphical way. Right? If that is possible, better. It must be verifiable. At any time, we must be able to verify. Right? For example, at any time you can verify your O-level results because it's in a system. And of course, good information must be secure. Otherwise, people will not use it. And it must be simple, accessible. Okay. Right. So that is where we stopped last time. Because we did a very small session last time because we did a little bit of introduction to the subject. Right. So now we'll move forward from that point. Now today we go very quickly, right? Because you have the basics of what is data, what is information, what is entity, and those things. Right. So we'll look at 2 factors of good information. First one is the value time factor and the cost factor. So when it comes to time factor, the highest value of information is at the information creation time. So then when the time pass by, the value goes down. So that is why we want to give the information. So every information system try to give the information as quickly as possible. Okay. For example, when you make a payment, so you want to get that SMS as quickly as possible. So that is where you are, because you are waiting for the SMS confirmation. So if you get it after 10 minutes, that is okay, but not as good as you get it immediately. You get the SMS at the end of the day is terrible, right? So why? The highest value of information is at the information creation time, because it's a competition, right? So the economy is a competition. So we try to give our best. We want to be the best. So therefore, every information system try to release the information as quickly as possible. Second one is the cost factor. So when we access information, sometimes we have to pay a value, cost. So if the value is, or the benefits are higher than the cost, so that means there's a value. People will use it. Otherwise, people will not use it, right? So that is why, for example, for some information free of charge, but some other information, they are not free of charge. And they are not free of charge. For example, now when we do a payment or bank transaction, we get SMS from the bank. That is an information. And we get a benefit from that information, that SMS. But in order to enable SMS, you have to pay a rental for the bank. It's not a big amount, maybe 500 rupees, but that is a cost. So anyone can say, no, I don't need the SMS. Right? I don't need the SMS. Then it's fine. But majority has enabled SMS because they feel like this cost is lesser than the benefit you get from that SMS. Okay. So value of information is benefit of the information minus cost of information. In some cases, this cost is zero, but there are situations cost is high. Okay, there's a cost. So therefore, we try to give highest benefit to the user, so that then even though there is a cost, the user will tolerate it. User will bear it. Okay. Right. So now we'll look at the life cycle of data. Right. So data goes through a life cycle of course data and information. So after sometimes your data is information, or we generate information or the results from data. So what is that life cycle? So in the very first few days, we have to understand these basics properly, because this is our IT is all about playing with data and converting that data into useful information, right? Whatever the application we are developing, we are using, that is what we are doing. Okay. So data is created. So there are different events that make data created. For example, when you go to the supermarket, I always use this example because this is something everyone is familiar, right? So you collect your items, goods to your basket and go to the cashier. So then that cashier will scan one by one. So every time item is scanned using the barcode, a data is created. Right? Every time it's scanned, data is created. So when a child is born, so we have to register that birth. So another set of record is created, another set of data, name, birth date, birth time, even a death, another set of data. When you go and start a bank account, set of data is created. When you do a money transaction, set of data is created. So you can see plain, right? So everywhere you do certain tasks, set of data is created. Right? So you do a reservation of a hotel room, data is created. Okay, so data is created. So if someone take your attendance, another set of data is created. Okay, so that is the number one for the starting point. So due to the certain events, data is created. business transactions, and so on. So then we have to manage that data. Right? We manage that data. And part of that data is taken into the data warehouse, so that we can use that for long-term analysis and so on. We'll discuss that later. And of course, after sometimes that data is no longer needed. So then we have to remove it. For example, your attendance record. Maybe your O-level grade 11 attendance records are still there, but definitely not your grade 1 attendance record. So they remove it. So maybe last year billings records are there in a supermarket, but not about 10 years ago transactions. So data is created, data is managed, and after sometimes we get rid of the data. We don't want to keep that forever. Okay. So that is the life cycle. Data create, data is managed, data is removed. Or then another set of data is created, managed, removed, and so on. And part of that data is taken into data warehouse for long-term analysis. But again, after sometimes these data will also be removed. But these in data warehouse, data remain for longer time, maybe another 10, 20, maybe even 100 years, data will be there. It depends on the type of data. Like weather data, it will remain for hundreds and hundreds of years. But billing data, sales data, maybe in the data warehouse, in your system, maybe 1 year. In the data warehouse, maybe 15 years. Okay. So you have to understand this life cycle. Okay. And why data goes through this life cycle. Not every data goes into data warehouse, only some critical data. Okay. So if you have any questions at any point, you need to ask, because I'm going very fast. So that is the idea in this class. We just concentrate on the points, important points, and we do it in with 2 hours. So therefore you have to ask if you have any doubts. Okay. Right. So we discuss the difference between IT and ICT, right? Because remember, you are doing A-level ICT, right? A-level ICT, whereas there are plenty of degrees and courses that we just refer to IT. Right? For example, I'm conducting classes for Bachelor of Information Technology, BIT. So it's basically the same. Only thing is when we say ICT, so we emphasize the importance of communication as well. But here the C is there, it's hidden, implicit. Okay, so therefore, don't worry. If you see IT or ICT, we pretty much mean the same. But when we say ICT, we little bit emphasize on the importance of communication as well. Okay. Right. So therefore, let's look at the communication also. Now, basically, I'm going through your subject, right? ICT, A-level ICT. So first of all, you must know your subject. So now you must have very good understanding about data, entity, information, right? And features of good information and so on. Now let's look at the communication. Of course, technologies, the technological aspects of that. Right. So what is communication? Again, we have to look at it in a very serious manner. Right? Very serious manner, because this is A-level subject. So what is communication? So can anyone tell me, according to your understanding, what is communication? Just I just want a casual answer. Because say when you decide I want to do ICT, at least you must have some idea about what is the subject, right? So do you have any idea about what is meant by communication? Because you have learned Sinhala, Tamil, English for at least 10 years, right? From grade 1 onwards. So languages are for communication. Now, can someone tell me what is communication? I'm not asking impossible questions. I'm not asking unfair questions, right? After learning languages, at least 2 languages for 10 years, can someone tell me what is communication? Because we will be learning more and more languages like Python, SQL, HTML, CSS. So those are also languages. What is communication? Anyone? Anyone? So you must be crying otherwise, right? After learning two languages for 10 years. If you can't answer what is communication, you must cry loudly. What we have done, going to schools for 10 years. Anyone, what is meant by communication? So I'm not asking what is Newton's first law, right? There's no hard and fast answer for this kind of question. Right.
A way of exchanging ideas?
Yes. So it's basically way of exchanging ideas, or the mechanism of exchanging ideas. So A has some sort of idea or something to communicate, and A want to let B knows it. So that is what communication is. Right. Right. So that is what communication is. So it's a very simple thing. Okay. So exchange of ideas, data, information between two parties. Of course, we don't communicate to ourselves, right? So what? So X is not going to communicate to X. That is not needed because your idea is with you. But maybe X want to communicate it to Y, and Y want to communicate something with X. So that is called communication. So that is your second part of your subject, right? Information and communication technology. So what type of communications are there? Of course, we have human-to-human communication. That is what you learn in two subjects in your O-level, your mother tongue and maybe English. Human-to-human communication, which is very important. Right? So why some of you guys are silent? Because you are not very sure about your communication. You are not very confident about your communication. After learning it for good 10 years. So then we have human to computer communication. Right? And we are really interested in this aspect in our ICT subject, because this is something you learn in your O level, and of course in the A level also. If you study English literature or whatever, again you are learning this. And the third one is computer to computer communication. Okay, so those are the three types of communications, the basic three types. And out of those, in ICT subject, we are interested in second and third. Right? Second and third aspects. So you all know what is human-to-human communication is, right? So we use human languages like English, Tamil, Sinhala, Chinese. So there are two different modes, the verbal or written. Of course, if someone cannot talk, someone we have to use, they will be using sign language, right? So the challenges in human-to-human communication is the most challenging thing is make sure that it's very clear. It's not unambiguous. So clarity and ambiguity, right? So if it is lack of clear, that means ambiguous. So we want to make sure that it's very clear. So when you give an answer also, that is your primary objective, right? So when you give me an answer, or when you go and face your exams, what is your main objective? Make sure your answers are up to the point, clear, not ambiguous. So that is why some students get A's, others get B's, C's. Maybe all of these have the same knowledge. So sometimes, of course, they lack knowledge, but sometimes the issue is you don't know how to communicate it properly. So when it comes to human communication, the most important thing is make it clear, make it simple, right? Make it up to the point. So those are important when you go for exams, when you go for interviews. Okay. When you ask a question in a class, when you write an assignment. Okay. Right. So then we have human to computer communication. So that is something we are really interested in our subject, ICT subject. Human to computer communication. And when it comes to human to computer communication, we are interested in two things. So one is, as software developers, programmers, we want to communicate our solution to the computer so that computer can execute it. Right? So that is what is meant by programming. Right? So that is what is meant by programming. So programming is a communication. So if someone is good at programming, of course, you have programming as a subtopic, right? You have Python language and so on. So if you want to good at your programming, so one of the aspect is, right? So you must know how to communicate your solution to the computer. So if you communicate the solution to the computer, then the computer can execute it. Right? Computer can execute it. So that is what is meant by programming. So programming is a communication task. So that is why we need a language. Right? So for communication tasks, we need language. So of course we use Python, Java, C# to communicate our solution to the computer, right? So therefore, just remember, if you want to good at programming, number one, you must be really good communicator. Of course, there are some other things like problem solving, logical thinking, and so on. But yes, communication is important. So then there's another. So that is the use of computer language to communicate our problem solution to the computer so that the computer can execute it. The second human to computer communication is when a human or user use an information system. Right? So when a user use an information system, there's a communication. For example, you go to a bank or someone goes to bank, ATM machine to withdraw some money. So there what you have to do. So you are given a user interface, right? You have to insert your card, right? ATM card, then enter your PIN number. So then you have to select your account. You have to select what is your transaction. Is it withdraw? Is it deposit? Is it money transfer? So now we are in a dialogue. So the user is in a dialogue with the computer. And of course, if you make it successful and if you have the balance, you will get the money if you are doing the withdrawal. So it's a communication between humans and computer, right? Human and computer. And as software developers, we facilitate that by providing the human computer interface or user interface. So that is also part of our task as IT professionals. Right? So that is also part of our task as part of our software development. Right? So you can see that I told you IT professionals are the best communicators in the world because we communicate with humans, we communicate with computers, and we facilitate computers to communicate with other computers. So do you think that IT professionals are not good communicators? IT professionals are the people who know the in and out of communication. Right? So no one else is as good as an IT professional when it comes to communication. Because they have never thought of these aspects. They are only doing human to human communication. Okay. So they are missing some aspect, but we cover all those. Okay. Right. As I told you, the third aspect of communication is computer to computer communication. Right. Computers need to communicate with other computers. For example, when I talk, you can hear. So basically, my computer communicate with your computer through internet. So that is what we have: computer networks, internet, and so on. Right. So computer networking is basically computer to computer communication. And of course, one of your biggest subject in A-level ICT is computer networks. And there's another computer to computer or device to device communication, that is Internet of Things, IoT. That is your final topic. Right? So networking is one of your middle topic. So you can see that. So look at the big picture. Right? So there's a big part of communication in our syllabus. So you have about 15, 16 topic. Out of those, programming is communication, networking is communication, IoT, part of that IoT is, yes, communication, facilitating these devices to communicate with each other. So therefore, no wonder your subject name is ICT. ICT. So when it comes to computer communication, there are challenges. Of course, we will look at those things in networking subject. So we need common standards. So that is why we have IP protocol, TCP protocol, HTTP protocol. We need addressing mechanisms. That is why we have IP addresses, MAC addresses. We need error handling. We need some reliability. Of course, that is why you have a subject called networking. Thanks. So don't worry, we will look at those things in detail there. So this is the mechanism of communication. Right? So first of all, you need at least two parties. So let's call them sender and receiver. So sender need to have something to communicate, some idea or some data to communicate. So then in order to communicate, we need a medium, a media. For example, if two people are talking to each other, the medium is air. If you are talking to someone in remote place, maybe you are using telecommunication. Right? So then you need to agree. How are you going to do the communication? That is called protocol. Right? So you may have heard the word like IP, Internet Protocol, TCP, Transmission Control Protocol, HTTP, Hypertext Transfer Protocols. So what is a protocol? Protocol is agreement. For example, at the beginning of the class, we agreed that we will be conducting the class in English, right? And some students also, so when they ask for A-level ICT class, they ask, what is your mode? Is it 100% English? Is it mixture of English and Sinhala? Is it Sinhala? Right? So our protocol is in this class, it is English. So protocol is agreement. If I all of a sudden start talking Chinese, of course, I can't understand Chinese. That is a different story. But if I start talking in Chinese, maybe you don't understand it. So anyway, we have not agreed that, right? Our protocol, our agreement is not Chinese. So we need to agree whether it's human to human or computer to computer or even human to computer. We need protocol. For example, human to computer, in your syllabus, our protocol is Python. So then we have to convert our idea into message. And when we convert it to message, we have to make sure that we follow the protocol. So then we can send it through our media to the other party. So the other party get the message. Because we have agreed on the protocol, the receiver can understand it. So then optionally, the receiver can send the feedback or the acknowledgement saying, okay, we got it, right? Okay, or whatever. Or maybe it can send, no, I didn't get the message, or the message is corrupted. Right? That is how the communication is done at high level. So in the very first session, understand what is communication is. Okay. Right. So now we have covered the first part of our topic. Data, information, entity, communication. Right. So this is just we are shaping the, right, clearing the ground for the big match. Okay. Right. Now we move on to the system. Right. Because why are we interested in systems? In your A-level ICT syllabus, we will be looking at so many different systems, right? In different topics. We will be looking at computer systems. Of course, already we are talking about the information systems, database management systems, okay? Operating systems is one of your topic. Database management system is another topic. The computer or the computer system is another topic. Of course, now we are discussing about the information systems. So you can see that everywhere the word system is there. So therefore, let's first understand what is system is, because otherwise you don't understand what is operating system. You don't understand. Of course, you may feel like you have understood, but you don't really understand. So that is what happens. Okay. So what is a system? So let's be serious again, right? Let's be serious again. What is a system? Okay. So what is the meaning of system when it comes to computer system, operating system, database management system, information system, and so on? So rather than going into those things, because we haven't discussed those topics yet. So let's start with something we can be all familiar, right? For example, we have a blood circulation system in our body, right? Blood circulation system. So we have a respiration system in our body, swasana paddhatiya. Digestive system. So how many systems are in within our body? And as a human, as a whole, again, it's a system. So you are a system and you have so many subsystems, digestive system, blood circulation systems. And of course, if you look at the nature, you have irrigation systems, right? So from rivers to the tanks, from tanks to the canals, to the paddy fields, and then the water has to get back from paddy fields to the extra water has to go back to again canals and maybe to the next set of fields. Irrigation system. So we have electric distribution system, hydroelectricity, and even a power plant is a system, right? So if you take a vehicle, it's a system. Vehicle is a system. If you take dynamo, it's a system. If you take a fan, it's a system. If you take a fridge, it's a system. If you take a washing machine, it's a system. Now can you think of what is a system? I gave you enough examples. Now, do you have an answer for this one? Very casual answer. What is a system? What is a system? Because you yourself is also a system. Right? Your vehicle is a system. Fridge is a system. And of course, we have the education system, irrigation system, telecommunication systems. So everywhere we have this word system. What is a system? So every system has an objective or set of objectives. Right? I hope you have objectives in your life. Right? You have objectives in your life. If you don't have any objectives, you are like I don't know, how do you call it? Have you seen kites where no the whatever the string is broken, it just goes, right? So no direction, no guidance. But if it is a system, every system has objective, right? For example, if you take a fridge, the objective is keep the things cool. If you take something like irrigation system, the objective of the system, there can be set of objectives. One of the objective is provide water to the cultivation. So if you take electric system, provide electricity for the industries and households, right? So every system has an objective or set of objectives. So then every system has subcomponents or components. Right? And these components communicate and collaborate. Communicate and collaborate. So this is super easy to understand, right? Don't memorize these things. So these things communicate and collaborate. Why? To achieve this one no set of objectives. Now, what is the definition of system? Now you can tell me what is the definition of system in a very formal manner. So remember, when you give an answer, not at the beginning. After studying the topic, you must be having the world's best answer. Right? You must be having the world's best answer. Now today there's a cricket match, right? I don't care about that cricket match at all. Why? Because I know there's a high probability Sri Lankan team will lose it with last 5 years of statistics. Because our team is not the world's best team. But about 10, 15 years ago, our team was the world's best team. So we won the World Cup, we won the T20. So get into that mindset again. Right, you guys, in your exams and so on. Your answer must be the world's best answer. You must not second to anyone. Right. So therefore, what is system? System is set of components that communicate and collaborate to achieve the given set of objectives, one or more objectives. So that is called a system. Okay, that is called a system. For example, if you take a vehicle, okay, so do you have any set of components? Can someone tell me what are the components in a vehicle or subcomponents in a vehicle like a car? Anyone? No one. Okay, first tell me what is the objective of a vehicle? What are the objectives of a vehicle? Facilitate transportation. Transportation of people and goods. So then what are the subcomponents that communicate and collaborate to achieve that objective? So then only I know that you have understood this advanced level topic. What are the subcomponents or subsystems in a vehicle that facilitate those two objectives? So of course, anyone? So I want the answers from you guys, right? Right, engine. So that is the
brake.
Sorry, brakes. Yes. Or let's say brake subsystem called brake subsystem. Engine. What else?
The steering wheel.
Sorry?
The steering wheel.
The steering wheel. Yes. You have the steering wheels. What else? You have the gearbox, another subsystem. Right? You have the alternators and so on to initiate the engine. Right? Some electrical systems are also there. Right? So those are all components or subsystems, but all those are collaborating with each other. For example, your gearbox is communicating with engine. So engine is communicating with, or the alternator is called communicating with engine. And of course the brakes, accelerator. So accelerator is communicating with the engine. So it increases the fuel and give more and more power. And of course your gearbox. So they are all collaborating one way or the other. And the objective is satisfied, that is, this moves from one place to another place with humans or any other things. Now, if you take blood circulation system, it's a subsystem. What is the objective of blood circulation system? Anyone? Rudira Sansarana Paddhati? After learning blood circulation system in your O-level, under science, what is the purpose of blood circulation or objective or set of objectives of blood circulation system? If you can't answer this question, you must be really crying. What kind of a person is me? After learning blood circulation system, I don't know the objectives of that. What are the objectives of blood circulation system? No objective. So then when the heart is not working, still the person is not dead.
Blood.
Sorry?
Delivering oxygenated blood to organs.
Yes, delivering oxygens to the organs. So that is one of the objective. Delivering oxygens to organs. So then only the organs can generate energy and function. So that is one usage. So there are some other usages also, right? Transporting, how do you call those? Hormones and so on. So those are also done part of the blood circulation. Okay. So in order to do that, your heart, lungs, right? So they tirelessly working, right? From your birth to the death, it's continuously working to achieve that objective. Even when you sleep, your blood circulation system is in operation. Right. Now you must have a very good understanding about what is a system is. Right. A system is set of components that communicate and collaborate to achieve one or set of objectives. So that is called a system. Right? It can be human, it can be a vehicle, it can be a power plant, it can be even a business organization, legal system, right? You name it. Okay. Right. So let's look at what are the different types of systems. Okay. Remember, this is your introduction to ICT. So there are different ways we can categorize them. So what, of course, even you can think of categorizations by yourself, but these are the categorizations given in your syllabus. Non-living systems versus living systems. Right? For example, vehicle, washing machine, power plant, non-living systems. A human, dog, even sort of a trees, in a certain level, it's a living system. Okay. So another categorization is natural system versus man-made system. Right? A lake is a natural system. Whereas a swimming pool, a power plant, man-made systems. Okay. Another classification, this is very important for us, physical systems and conceptual systems. Right? If you take a vehicle, physical means you can touch it, tangible. A power plant, physical. Of course, it generates energy or electricity, but the system is physical. Then we have conceptual system. That means you can't touch that system. And of course, in ICT subject, we are pretty much interested in conceptual systems. Operating system, database management system, information system. So they are purely what? Software. Software is a concept. But we are interested in one physical system. What is that? Operating system, database management system, information system, 100% conceptual. But we are interested in one particular system in our ICT subject, which is at least partly physical. What is that system? Anyone? I already mentioned that word few times today. What is that system? Where there's a physical component, though it is not 100% physical. Anyone? So if you are very serious in this class, you must be able to give me the answer. So I few times mentioned these words: operating system, database management, information systems. All those times I mentioned another one. What is that? Which has a physical component? What is that? Anyone? So anyone who has paid attention to this subject, or anyone who is in this class in a lot of seriousness? No one. Computer systems. So actually computer system is our topic number 2. So when it comes to computer system, of course, you have a laptop or desktop or smartphone. So there's a physical aspect. But there's no physical thing for OS, database, information system. But all these things resides in computer system. Right? So therefore, computer system has a hardware component. When you take overall, right? Physical versus conceptual systems. Another classification is non-adaptive systems versus adaptive system. Okay. So what is mean by adapt? Adapt, not adopt. adapt. Adapt again what? So we say adapt to the situation, adapt to the environment. So that means you adjust, you change accordingly. Right? You change accordingly. That is called adapt. For example, you guys have adapt with the technology. That is why you guys are in online class. But some others, even after another 100 years, they will be looking at physical classes. So okay. So they don't adapt. Of course, there are plenty of IT professionals who work from home. Work from home because they can do it because information they are involved in developing information system. So information system is not a physical system. So therefore, they can do it from anywhere in the world. Even when the software developer is in Antarctica, as long as he or she has the internet connection, he can be part of the team. But a civil engineer, electrician, no. They need to be there in physical presence. Okay. Right. So what is adaptive system? Adaptive system is a system which adapt. That is a system that change to according to the environment. A very good example is a smartphone. Right, smartphone. So smartphone can adjust, right? For example, when you go outside, all of a sudden the screen brightness is increased. So when you change your orientation, it can auto change the orientation of your video or something. When it is night, it can adapt to the night vision or blue color mode. So those are all what? Adaptations. So those are adaptive systems. So you can see that is one of the reasons why we call it smart. So smart devices, smart peoples, they are adaptive. They adapt to the situation. Dumb people, they don't know how to adapt because they are dumb. Because they are dumb, they don't know how to adapt. So they just stay the same. The environment is changed, but they just stay the same. Just like this old telephone. So that is a dumb telephone where this is a smartphone. Because this is not an adaptive system, this is adaptive system. So what we need to build more and more is adaptive system. So as software developers, IT professionals, we really like to produce, develop adaptive systems. That is what the users really like. Okay. Right. And the final classification is, this is super important for your exams because they have even asked this in the exams past papers, the closed system versus open system. Okay. So open system is, let's take the open system first. So we have a system, the inputs are coming from outside and maybe outputs are going out to the environment. So then we say it's an open system. It's an open system. Right? Very good example is information system, right? We say it's a banking system. So we outsiders, we are not from the bank, but we can access the system. We can input our ATM card, our password. Then of course we can take our money and go out, or we can get the receipt and so on. So that is an open system. And almost all the practical systems are open systems because otherwise it's a useless system. So closed system is where you take your input and output also within the boundary. You take inputs and you give the output, but you don't go beyond the boundary. So therefore, theoretically, closed systems are sort of a useless systems. Right? Useless systems. But there are fairly closed systems. So we can say a system is fairly closed, fairly open. But if it is 100% closed, it is sort of a useless system. So can someone give me an example of a fairly closed system, if not 100% closed? So that means almost all those things are happening inside the environment. Very rarely there is interaction with the outside. Can you give me example? It's an open question. Anyone can come up with different answers. Fairly closed system. Yeah, so I try to get the example from you guys first, right? So anyone? So there, where the system is, all the activities are within the boundary. Within the boundary. Very rarely there's a interaction outside the boundary. Can you give me example? Just look, I am not expecting correct answers because I have not covered this topic yet, right? So now I am expecting actually wrong answers. Or I don't mind whether it's correct or wrong, right? I'm just checking whether you can at least think. But after maybe if you have done this topic yes last week, of course today I'm expecting correct answers. Can you think of a closed system, example of a closed system or fairly closed system? Or can you give me two systems saying that, okay, this is more open, this is more closed? At least something like that. Right. Pressure cooker is yes. So that is a very good example. So once you close it, it's closed system, but it's not 100% closed system. Why? To the pressure cooker, right? So you have the pressure cooker. To the pressure cooker, you add your things from outside. So therefore, it is not 100% closed system. But it's that answer is okay, correct, because once it's in operation, it's a closed system. Right? It's not like your normal kettle. Right? Your kettle, it can the output or the exhaust or the steam can go out, but not in a pressure cooker. Of course, in the pressure cooker also, some time to time they can release the pressure, but it's more close. So that is a very good example of a fairly closed system. Okay. Now, you know that there's something called International Space Station. Right? International Space Station. So it's a fairly closed system. It's not 100% closed because time to time, maybe once a year, set of astronauts goes and another set of astronauts comes. But so they have to survive inside that, food and everything. But of course, they can, there's a communication and so on. So therefore, it's not 100% closed, but it's a fairly closed system. Another example is your school is fairly closed system. Because you are supposed to be there at 7:30, you are not supposed to go out until 1:30. But it's not 100% closed because you can go out after 1:30. So therefore, it's fairly closed system. But if you take something like a tuition class, relatively open system because it's less strictly controlled. Less strictly controlled. If you feel like the topic is boring, of course you can. Sometimes some teachers may not allow it, but most of the time you can just go. Maybe you can go home in the break, but you can't do that in the school and you will be punished. So relatively, this is more close. This is relatively open. Okay. So if you take something like a website, it's fairly open system. But if you take a banking system, it's more closed system. So only thing is we can just compare relatively closed, relatively open. Okay. Right. So I hope now you have fairly good understanding about what is closed system, what is open system. The student who asked that question. So when you draw a boundary, so if it is a school, that is your walls. So school is theoretically open system because you go from outside and you can come out after 1:30. So therefore your school is an open system. So theoretically everything is open system, but there are fairly closed systems like International Space Station. For example, school is fairly open, whereas prison is fairly closed. Compared to school, prison is more closed. Again, not 100% closed, because people are getting to the prison from outside. Some people they are released to the society again. Okay, right. So that is the difference between closed system and open system. And later we will look at something like free and open source software, right? Open systems, right? For example, OSI architecture, open system interconnection architecture, when we discuss networking. So we'll use these words, okay? Open standards, right? Closed standards, and so on. Okay, right. So I already mentioned you, why are we interested in systems? Because throughout our ICT subject, we will look at information systems, computer systems, operating systems, database management systems, and so on. So therefore, now I hope you have very good understanding about what is a system is. Right? What is a system is? System is set of components that communicate and collaborate to achieve one or set of objectives. Remember, your answer must be the world's best. So then you don't have to worry, you can go anywhere in the world and live. Okay. Right. So now we move on to information system. So remember, we are interested in all these systems. So let's look at our first of that system, information system. So information system is a system that convert process your data into information or results. Okay. So what is the information system? Information system is a system, right, that process your data into results or information. So that is called information system. Like the billing system in a supermarket, banking system, student management system. So it convert your data or process your data into information. So what are the key components of information system? Of course, you have the data, which is sort of input. Your information system process your data and produce the output called information or process data or the results. And when it comes to information system, there's another important component, that is feedback. And that is feedback. So that is what you guys are not used to. So that is why when I ask questions, you guys very rarely give me answers. Only one or two. Others feel like, no, that is not needed. Because that is the way you study in your schools. ඔයගොල්ලෝ දැකලා නැත්නම් ඉස්කෝලේ ගහලා තියෙන බෝඩ් එකේ නිශ්ශබ්දව සිටින්න. නිශ්ශබ්දතාවය රකින්න. Because that system does not promote feedbacks. Can you give feedback about your teacher to the principal directly? I don't know. Do they take feedback about your teachers every term? And you give your honest feedback about your teachers? I don't think so. Because those systems that is why those systems are not very efficient. But in a tuition class, in an institute, you can give your feedback. Right? Of course, we always welcome your feedbacks because we want to improve things. So what are the components of an information system? Data, process, information, feedback. Feedback is connected to both process and data. Why? The feedback is needed if you get wrong information. So then maybe the issue is with data. So we know that there's something wrong with data because we get the feedback. And because we get the feedback, we know that there's some issues with the processing. Right? So without the feedback, we cannot improve it. We cannot fix issues. The issues will be there forever. We cannot improve things. So in order to improve systems, we need feedback. So therefore, what are the components of information system? Data, process, information, and feedback. Okay. Data, process, information, and feedback. So what is information system? A system that transform or process data into information. And it has so many components, right? Of course, it's built on hardware computer systems. An information system may have database component or database management system also collaborating. It is getting the help from the operating system. And your information system have different modules, maybe inventory module, account module, right? Order processing modules, and so on. So those are the things that we will be learning in your other topics. Okay. But this is the time for you to understand what is an information system is. Okay. Right. Any questions? Right. So we discuss about what is information system is. An information system is a system that processes data into information or results. So this is your note. I'm not giving you note because I don't want to waste your time. Because when I studied, I found it extremely boring to write down notes. I thought it's a waste of time. Time waste. So therefore, I don't want to do the same thing for the next generation. So that is why I have given you the note. Right? So your task is not taking note. Your task is actively involved in this discussion, actively think about that subject. So your brain must be 100% running right now. Right? 100%. Not your hands and memory and other things. Okay. Because education is, studying is not memorizing things. Studying is look at the concepts, break down into sub-concepts, see how things are related, look at what are the usages, then compare different things, pros, cons, right? Which one is better, so on. So those are the guys that will take decisions in the future. Those are the guys who will build the future. Others, they are just passing exams and, right? So become a burden to the society, right? So they will get the certificates, but they don't have any personality. They don't have any competencies. So they become burden to the society. අර කියන රැකියාව විරිදු උපාධාරීන් එහෙම කියලා ඉන්න කාලකන්ණි. බරක් රටට. Right. So now let's look at the evolution of information systems. So these days we are talking about computer-based information systems, right? Banking systems, accounting systems, payroll systems, and so on. But that is now. Before computers came, we had manual information systems. Manual information systems. So manual information system means no computer involved, no information, digital or electronic processing. But now we have computer-based information systems. We call them CBIS as acronym. Computer-based information system. Because information system is information system. Even manual, it's an information system, right? But here we use computers to do that processing, store those results, store the data. Can you give me an example of a manual information system you have seen in the society? So now I'm checking whether you have the thinking power. Are you a critical thinker? Are you keep your eyes open to the society? Again, I'm not expecting perfect answers. I don't mind you give me a wrong answer because still we haven't discussed this. But can you give me an example of a manual information system you have seen in the society?
Telephone directory.
Telephone directory. Yes, correct. That is perfect answer. It's a manual information system where we have to take that sort of a book and search for a particular name and find out what is the telephone number of that particular person. And you know that these days, I don't think now the telecom is even delivering directories unless you request. right? Because now we have online or computer-based information system for that. Okay, right? Any other example? Yeah, so that is accounting done manually using, so we call it bookkeeping, right? Journals, ledgers, right? So the staff members do it manually. Another example, if you go to maybe a small shop or something, they will prepare the bill manually. It's a manual information system. Whereas if you go to the supermarket, most probably it's a computer-based information system and you just get the receipt, or maybe even you swipe your credit card and do the payment also. Right? So maybe you don't get the bill also. You can say, no, I don't need the bill. As long as I get the SMS confirming the payment and you guys can send me the bill to my email or SMS, I'm fine. No physical paper or nothing. Right. So that is the difference between manual information system versus computer-based information system. So manual information systems use physical media to store, like paper, files, processed by humans, calculations and other things. And the transmission is also by humans. So sometimes vehicle is needed to transfer that file from Kandy to Colombo. It's a headache. It's very inefficient. It's something for the past. Still in Sri Lanka, plenty of manual information systems, especially in government sector, unfortunately, because these guys are not adaptive. The private sector is adaptive, fast, but plenty of government information systems are like land registries, right, courts, so many manual information systems. It's a headache to the people, headache to the society, because these guys, they don't know how to get into the next level. So what are the disadvantages? So we need a lot of space. You have seen how many piles are in a government office. It's very slow to process. Very slow to process. Possibility of errors, human errors, possibility of corruption, because humans can deliberately do corruption. Even delaying things is also corruption. Then they have to pay bribes. So delaying is part of the corruption. So if there's office which keep delaying things, so that means all these people are highly corrupted. Kalakandi. So those are the issues with manual information systems. But when it comes to computer-based information systems, so we can automate input, we can store electronically, obviously we process electronically using microprocessors, software. And not only that, we can even transmit electronically. Right? We can do file transfer, we can transmit data from one place to another, even to another country within a split of a second. And plenty of advantages. So you need less space, no physical files, folders, lightning fast processing, less errors, no room for corruption. That is why a lot of people, right? So they oppose CBISs, because then they can't do their bribes, corruption. Okay, CBISs, computer-based information systems. So as IT professionals, one of our tasks is convert those manual information systems into CBIS and then managing those CBISs. So that is our task. Right, now let's look at what are the components of a CBIS, computer-based information system. So this is super important. You know what are the components exactly. There are 6 components. So CBIS means the total thing, which does the processing of data into information or results. Of course, we need hardware, right? Microprocessor, motherboard, and so on. Then we need software, which includes operating systems and other software like application software. We'll look at the difference between system software, application software later. But information system, CBISs need software. So most of the CBISs need networks, not all, but most. So then only we can store data in a different place. Users can access that system from home. We can transfer data from one place to another, or one system communicate with another system. So we need networks. And of course, we need databases. So in modern terminology or in modern CBISs, we don't keep data in files or even computer files. We keep it in a database. So that is why you have a subject called database in your A-level ICT syllabus. Okay. Of course, database is a special type of software, but because database is a special, really important one, though we mention it as a software, we take database separately also. But technically, database is also a software. Then, of course, we need use people. So we can't say that CBISs doesn't need, or CBISs don't need any human interaction. Still, we need. Right? Maybe enter data, right? Maintaining that system, creating user accounts, monitoring, and so on. Yes, we need system administrators, system users, operators. And of course, when peoples are there, there's a possibility of corruption, misuse. So therefore, we need policies and procedures. Who can do what? Right? How frequently we have to take backups? Right? What are the things that users can do? What are the things the users cannot do? Policies and procedures. So those are the 6 components of a CBIS: hardware, software, network, database, people, or sometimes we call it liveware because we always use hardware, software, and so on. And of course, the policies and procedures. So if in the exams, if they ask what are the components of CBIS, you have to say these are the 6 components. And if you want to get 100% marks. Okay. Now, I don't care whether you got how many A's for your O-level. Right? I don't care. Maybe you have A for maths, A for science, A for O-level ICT. I don't care. But make sure, keep it a habit, you go for A's. You go for A's. And of course, at the end, you may not get A. That is fine. I don't want everyone to get A's, right? If you don't get A, that is fine. But your objective must be do and get the exceptional results as much as possible. At least give it a try. Give it a try. Then it will become a habit for you guys. Right? Habit. So whatever you do, you try to get the best. So then we call your exceptional case. So that is how people become exceptionals, right? So I told you that I don't care about today's match because Sri Lankan team is not the exceptional category, at least not in the top 3. So I don't care that kind of cricket match. I don't care. I don't care that kind of cricket match. If they get into the top 3 at least, I will start watching cricket matches again. Definitely. Okay. But we are not used to that kind of getting defeated. It's a pain for us. It's a pain for us. I don't know, is it a pain for those players? I don't see that they are worried about getting defeated, right? But we are really worried about that. So therefore, we don't want even to see it. So I don't want to go to exam and fail. That is not something I used to. Okay. Right. So what are the CBIS components? Hardware, software, network, database, people, and policies and procedures. Now let's look at in little bit more details what are the steps in data processing? Because we already look at this, right? So data creation, data processing, the removal of obsolete data. But let's dig into little bit more details now. So we have to, once the data is created, right? So it won't automatically come into our system saying that, okay, I am a new data, please enter me, right? So we have to gather it. We have to gather it. So now we look at it in the perspective of a system, information system. So the information system need a way to gather data. Maybe entering data using keyboard, or maybe scanning, or you enter your ATM card and so on. So gathering data. So then we can do validations. So we can do validations. So when it comes to information system, remember we have the input, we have the output. So input is your data, output is your information or results. So this accuracy or effectiveness of information depends on two factors. Can someone tell me what are those two factors? Effectiveness. Effective means does the work. It work. Accuracy depends on two things. What are those two factors of information system that determine the right information? Effective information. So those who have done O-level ICT, at least, so others, can you guess what are those two factors?
Timeliness, accuracy.
Can you repeat the question answer?
I mean, the qualities of information are accuracy, timeliness, like that.
No, that is the qualities of good information. So I'm now asking that question in a slightly different way. Now we are talking about information system. So for an information system, we input data and we get the information. So that good information. So sometimes we may get good information, sometimes we may get bad information, right? So but my question is, which two factors determine or affect getting good information? It's a very difficult question. It's a difficult question in the sense you have to guess what I'm looking for. But your answer has about 50. Actually, one of the factor is in your answer, but you have to put it into the proper context. It's a very conceptual question I'm asking. Remember, here we get it process.
We need to give correct instructions, correct data.
Yes, absolutely correct answer. 100% spot on, right? So we have to make sure that the processing is properly done, right? So that is, the program is free of bugs. Processing is properly done, right? Correct processing. Second thing is we have to make sure that we do not input wrong information, wrong data, right? So we use a nice statement for that. Anyone who is aware of that? So that means if you don't input correct data, what you get is wrong data. So correct processing, correct data. So in order to explain this in IT field, we use a nice statement. Can someone tell me what is that statement? So that means if wrong data, what you get is wrong information. So we use acronym for that. 4-letter acronym. You know what is acronym is, right? For example, UNESCO is acronym, right? OS is acronym. So likewise, we have a 4-letter acronym to explain the importance of accuracy of data. Can someone, maybe you have heard this. So maybe at least some of you may have heard this. It's a 4-letter acronym that describes this. Have you ever seen this GIGO? Anyone who has seen this? Can someone tell me what is GIGO? So this is not a stat, it's sort of a statement we use it by IT professionals. Remember, there are some terms we use, right? Bug, right? Debugging, compile. So IT people use those things. So similar term is garbage in, garbage out. It doesn't matter how accurate your system is. If you input garbage, what you get is garbage, right? It doesn't matter how well your washing machine is working. If you input dirty cloth, you may get clean cloth. But if you dump garbage, of course you are going to get garbage, right? Because garbage, by washing garbage, you don't get clean cloth. So it doesn't matter how well your processor or your washing machine is, you have to make sure that you input the correct things. It can be dirty, but it must be dirty cloth, not garbage. So same thing, it doesn't matter how well your programs are run, developed, programmed. If you input garbage, what you get is garbage. So that is why we need to do data validation. That is why we need to do data validation. So otherwise, if someone enter wrong data, you are getting garbage information. Okay, right. So you must know the reason, right? GIGO, prevent this. We have to do data validation. Right. So then either we can process and store or store and process. So sometimes we store and again process and again store. It doesn't matter. Okay, let's take store, and then of course we have to process. Then we can output the data, or rather we can say output the information or results. Okay. So what are the steps? Now we go into a little bit more details. Data gather, data validate to prevent GIGO, data store, process, and output. Better if you can make it something like information output, but sometimes we use the word data information interchangeably. Okay. Right. So now let's look at one by one, right? Because this is what software development is, right? Software development is make an information system having these features. So it has the data gathering, user interfaces, and so on. We do proper validations. We have to store it, right? Store it to a file. When you are doing programming, you will learn how the Python can be used to store data in a file, then read that data from the file. And of course, how to process. So you will learn operators, control structures, methods, okay. And of course, data output. Right. Command line output, graphical user interface. Maybe you want output as a report, graph, table. So this is where you learn, get a feeling about what is software development. What does information systems do? Okay. So gather, validate, store, process, and output. Okay. Store, process, and output. Right. So when it comes to gathering data, what are the important things that we have to consider? Right. Because at the end of A-level ICT, you must be able to build good information systems. You must be able to compare two systems and say okay, this system is better than the other one in these aspects. So when it comes to gathering data, gathering means we capture the data into our information system. So what are the things we have to consider? We have to make sure that it's very efficient, right? Very efficient. So we can do it quickly, right? So when it comes to, for example, I don't know how many of you guys are using banks, right? Or credit, debit card or something maybe, right? So you may be having a card, right? So when you are in the ATM, sometimes there's a queue and we are very impatient, right? So we want this guy to do this quickly because we also want to get that done. So one reason maybe if that person is taking too much of time, maybe this guy is not very confident of using the information system. Okay, so that can happen. Of course, then we have to tolerate because not everyone is as good as we, right? So some people are not as comfortable as us when it comes to using computers. That is fine. But sometimes the issue is the user interface is not good. It's not very intuitive. So we get confused. Even we get confused sometimes. What to do next? But good user interfaces always they make it very efficient. Right? So they make it efficient. So that is why in the supermarket they just scan it rather than entering. And of course, we want to make it user friendly. So users can do it in a very easy manner. So when it comes to gathering, then the users will like it. Right? So there are 3 approaches when it comes to data gathering. Of course, we are talking about the computer-based information systems, okay, CBISs. So even though it's a CBIS, sometimes the data gathering is manual. So that means we just have to using keyboard, you have to just enter it one by one. So then we say it's manually we are entering data. But if it is something like scanning, so that is semi-automated. Still we need an operator or user. But it's getting faster. So then we say we are into the semi-automated data gathering. But if there's no need of a cashier, say we can just gather the data and maybe send it through a scanning machine and we get the bill. Or if you have an account with them, or we can swipe out credit card and the payment is also done. So that is called fully automated data gathering. Fully automated data gathering. So that is the final or ultimate objective of data gathering. We may not be able to do this for all the data gathering, but as much as possible, we want to get into this level. Right? Manual, semi-automated, fully automated. Okay, fully automated. Right. When it comes to data validation, what are the things we are interested? Validations. Remember, otherwise garbage in, garbage out. Okay, garbage in, garbage out. Now you may have entered data to so many different applications, right? For example, even when you register for the class, I ask you to fill the Google form. So there are some validations. Now, can someone tell me what are the type of validations you have seen? Just 1 or 2 type of validations. So there are mandatory fields, right? Without entering a data for that field, you can't proceed. Right? So that is a validation. So we call it what? Presence check. So we call it mandatory fields. You must enter data for that. Otherwise, it doesn't make sense. For example, you can't create a user account without giving the username, right? We can't do a money transfer without you telling what is the amount. So it's a must field. So that validation is called presence check. So then we can do data type checks. For example, if it is an amount, you can't say hello. Right? You can't transfer hello from one bank account to the other bank account, right? The marks cannot be something like hi. Data type checks, right? A date cannot be animal. So date must be something like 2023, 10/30 or something like that. So we call it data type checks. We can do that. We can check whether it's a valid data type for that particular data. We can do range checks. For example, if it is a marks, usually we check whether it's between 0 to 100. Right? If it is a money transfer, we can at least check whether it's a positive value. Range. Right? Format checks. For example, if it is an email address, you need to have something like this. Right? nimal.pereira@gmail.com. So this dot is optional, but this part is there. right? This ampersand is there, this dot is there, right? Gmail.com, Yahoo.com. Here it is, this dot is optional. Or it can be nimal@gmail.com. So we can check whether these parts are there. If ampersand is not missing, it will say your email address is invalid. Okay. If this dot is not there, it will say this email address is invalid. Format checks. So we can do presence check, we can do data type checks, we can do range checks, we can do format checks. Of course, there are some other checks also, but we just look at the basic or the major type of checks. Okay. Because remember, otherwise, garbage in, garbage out. If your email address is invalid, no point taking that email, because we will not be able to communicate with you. We may not be able to give you the access. Okay. Right. So now we discuss about data gathering, data validation. So next one is data storage, or process and storage, or storage and process. Okay. Right. When it comes to storage, there are two ways we can do. Either we store in our premises, which is now getting less and less common, but that used to be the most popular approach about 10 years ago. That means, say, so you will log in. For example, say now you guys have uploaded, enter your details into the Google form, registration form. But that result is not in our premises. It's in a cloud storage. It's in a cloud storage. But there are situations like banks, they don't like to keep the data in cloud or some other place in the internet. They want to keep it in the bank, or at least the head office or their data center, due to security reasons. Right. So then we say it's a local on-premise storage. Or if you keep it in a third-party location in the internet, you call it cloud storage. Right. For example, we use cloud storage. All your documents in the Google Classroom, they are in the cloud. The recordings are uploaded to the YouTube as a private video. It's in the cloud, YouTube cloud. Right. So your forms and other things are in the Google Drive. It's in the cloud. So we don't care about keeping them. But if it is something like a bank, they prefer to keep almost everything in their local storage because of the high security and privacy issues. Okay. So store locally or store in the cloud or remotely. Right. Now we move on to the processing. Right. Because we talk about data. Let's look at the three types of data also. Right. Three types of data. So we can categorize the data into structured data, semi-structured data, and unstructured data. Now today we covered a lot of things. Now after the end of this session, few slides. So then I will show you the syllabus and show you, okay, we have done these and these, then these subtopics. Okay. Right. So what are the three types of data? Structured data, semi-structured data, unstructured data. What is the meaning of structure? Structure, sarcasm. Structure again. When you write an essay, you need to have a proper structure. When you build a building, you need a proper structure. Bridge, you need a proper structure. So those who do the technology, so there's something called structural design. Right. So structured data means the data has a well-defined structure. So those are the data we use to process in computer or CBISS, structured data. Like student information, name, date of birth, gender, right? Email, well-defined structure. Employee details, a bill, right? So what is the structure of a bill? So you have the quantity, you have the item code, item name, unit price, quantity, then of course the subtotal. So then for the next one, so then your final total and maybe the date of the billing, the user. So there's a well-defined structure, right? payment details, student details, employee details, transactions. Right? So those are marks, well-defined structure is there. And we will look at how to manipulate the structured data in our database subject. Structured data. So we have the structured query language, SQL. Right? SQL, structured query language, to query, retrieve, update, delete these kind of data, payment related, employee related, student related, marks, something like that. Okay, so what is the first category of data? Structured data. So the second category, let's look at the other extreme, unstructured data. Right? Unstructured data. So unstructured data is a data having a very little structure or no structure. Right? Very little structure or no structure. So traditionally, we thought IT is not interested about unstructured data. IT is all about processing structured data. But it is no longer the case. Now there are plenty of information systems which process unstructured data, and there are plenty of businesses operate on unstructured data. And another name for unstructured data is big data. So you will see this word over and over in your syllabus, big data. When someone says big data, it is basically referring to unstructured data. Okay. So unstructured data involves something like images, audio, video, and sometimes even some text. There also, it can be unstructured. If it is something like letter or something, or it can be even semi-structured as well. But definitely images, audio, video, they are pretty much unstructured data. Okay. So if you take these applications like YouTube, a lot of social media, so they are really interested in unstructured data. And those are big businesses, right? Because even the CCTV footages, recordings, so those are big data, unstructured data. So people are taking a lot of photos, video calls. Now, right now, this session is getting recorded. And of course, that recording is unstructured data, which I will be uploading to YouTube and giving you the access in case you miss the session. So that is unstructured data. So therefore, unstructured data is super important in modern society. But about 20 years ago, IT was all about processing structured data. But you can see that we have already moved from processing structured data into processing unstructured data. And in the future, more and more unstructured data will be processed. Okay. Right. So the in-between is the semi-structured data. So that is, it is not as structured like a student record. At the same time, it is not as unstructured as just an audio or video. It has some sort of a structure, but it is not well structured. Right? For example, a social media posting, blog post. Right? It has some sort of a structure like this is the post, these are the comments, these are the replies to the comments, and so on. But inside it is just set of text that people write. So those are semi-structured data. Those are semi-structured data. Okay. So we can't just draw a line and say this is structured, this is unstructured, and this is semi-structured. Of course, in general, only we can say, we can agree that, okay, this is more semi-structured, this is more unstructured, this is more structured. Okay. So there's no hard and fast rule saying this is where this move from structured to semi-structured, right? So usually we have the NoSQL databases to keep semi-structured and unstructured data, whereas SQL databases we use for structured data. Don't worry, we will be looking at those things in detail when we look at database. Okay. So those are some unstructured data types: text, audio, videos. A lot of sensors are generating a lot of data, right? GPS related data and so on. Right. So these are some features or characteristic of unstructured data, which is important for your exams. Okay. Because you have to face the exams also at the end, and it's a very competitive exam anyway. What are the features of unstructured data or the big data? Okay, big data. So one of the feature is they comes in big volumes. Right. For example, if you have a CCTV camera, within a day, right, it may record about few gigabytes of data. Now this session is generating big data, right? So this session has generated at least about 400 megabyte of data, big data, audio, video, and so on. So big data comes in, or unstructured data mostly comes in big volumes, not few bytes or kilobytes, in megabytes, kilo and gigabytes, and sometimes even terabytes. And you can easily, remember also, they are all starting with V. We call these 4 V's of big data. First one is volume. Second one is variety. So it can be audio, it can be video, it can be some text, it can be images. So different variety of data is coming under unstructured data. The third one is velocity. It comes in quick and fast. Right? For example, now you can see, you can join this session, right? So you are getting megabytes of data every second, right? From this my Zoom client to your Zoom client, right? So that is the nature of big data. So if application, for example, Zoom is an application that handle big data, unstructured data. So therefore, it has to handle this high velocity of data generation, high volume, high velocity, these different variety. So my audio, my screen shared video, sometimes even the text, your chat is a script. And the fourth one is veracity. So veracity means the difference in quality. Difference in quality. For example, so my audio quality is different from your audio quality. Maybe because of the difference of the sound card. My cam is maybe having higher resolution than your cam. And also it depends on the network speed. Even though my cam is high sensitive, maybe the network speed has limited bandwidth. So therefore, I have to send it at a low resolution. And different people may be expecting different quality. So that is called veracity. Different cameras, different audios, different networks results in different quality of the same data. So we call them 4 V's of big data. So characteristic of big data: volume, variety, velocity, and veracity. Okay. So it's super important for your exams. Right. So there are plenty of usages of big data. Right? Big data. So business, marketing, scientific research, right? Security, like analyzing CCTV footages, healthcare. Now all those scanners are big data. The CT scan, MRI scan. So those are generating images and sometimes even videos. Weather, so satellite images. Right? For example, right now, why can't I open this? Let's say weather. So this is generated by what? Big data. So with the satellite image, with the help of the satellite data, so they are simulating what is happening right now. What is happening right now in the Sri Lanka, not only Sri Lanka, all over the world. So right now there are high possibility of rain in these areas, but not these areas, right? So that information, this is the information you are looking at, is generated by getting different satellite related information and pressure, humidity, and so many other details. Okay, so that is also big data. Right? That is also big data. So therefore, big data is super important. Right? Super important. YouTube, TikTok. So they're all big businesses based on big data. Right. So finally, we move on to the processing. Remember, we discussed about gathering, validations, storage, right? That is what we discussed about data and different type of data. And now we look at the processing. So when it comes to processing, we can do processing in two different ways. Of course, there are so many things we can discuss about processing, like use of AI-based processing, non-AI-based processing, and so on. But let's not get into that kind of a deep discussion right now. But when it comes to processing, we can identify two approaches in processing. What are those two approaches? Either we can do batch processing or online real-time processing. Right? Online real-time, OLRT. So batch processing means we process it batch-wise. At the end of each day, or maybe at the end of each week, only we process it, or maybe at the end of each month, or at the end of each year, or when there's a such event happens. So those are called batch processing, right? For example, calculating salary of employees. If the salary is given only once a month, so that's naturally a batch process, right? Generating your electricity bill, it's a batch process, right? Generating the exam results. So O-level exam results once a year. A-level exam results once a year. It's a batch process. So they're naturally batch processing. So therefore, that is good enough. That is good enough to do it as a batch processing, because that is naturally what we have to do. But there are situations batch processing is not good enough. We have to go for online real-time processing. Online means gather online, system is connected. Real-time means when you enter data, immediately it's getting processed in the server or in the machine. For example, when you do a money transfer, it's a online real-time. So within few seconds, the other guys get a SMS saying money has been transferred to your account. Maybe your bank is Sampath Bank, the other bank is Ceylon Bank. So it happens within few seconds or within split of a second. When you do a reserve a seat, airline seat, or you book a hotel room, immediately it is happen, because otherwise another person will reserve the same seat. Okay, so those are online real-time processing. When you do a credit card payment, right? So those are online real-time processing. Whereas batch processing is maybe once a week, once a month, once a particular event happened, and so on. So you must know the difference between batch processing and online real. We can't say one is better than the other, because in some cases batch processing is good enough. That is a natural. But if online real time is needed, we have to go for that. Okay. Right. So this is our final slide. Some new trends. Of course, when we say new trends, these are not that new, but relatively new. Okay. Of course, these days the number one hot topic is AI. Right? AI, artificial intelligence. robotics, cloud computing, mobile computing. Right? More and more people access information systems, transactions using mobile or smartphones, smart technologies, right? Big data analysis. Remember, big data is unstructured data. So, for example, right now I showed you the weather forecast. It's a big data analysis with according with the result of big data analysis. They say this is your forecast. Internet of Things, augmented reality and virtual reality. So we'll look at those things in different topics. Okay, a blockchain technology like cryptocurrencies, bitcoins, quantum computing is another area, right? So now the computer engineers and scientists have developed quantum computers, which operates using quantum mechanisms rather than conventional electricity and electronic concepts. Okay, so those are relatively new trends, and some of these are already has become reality and they get improved day and day, and some other areas are still in research like quantum computing. Okay, right. So today you learned so many things, right? So many things, tons of things. Now let's go through your syllabus and see whether we have covered, because at the end your syllabus must be covered, right? Your syllabus must be covered and you must be prepared for the exams. That is the objective of a class, right? Not telling you stories, gossips and other things. Okay, so therefore let's see whether we have achieved our primary objective so that you can start preparing for the exams, right? So remember, we are in the topic number 1, concept of ICT. So you have how many topics? 12 topics. Okay, so we are in the middle of the concept of ICT. We go very fast, right? We go very fast. We don't want to waste time, right? So I told you in the very first day, I want you to be in the cricket grounds, right? Flying kites, talking to your friends, not in tuition classes and schools. So that is what the developed countries have done. So you guys are unfortunate guys, right? Most of you guys, you spend about 6-7 hours in the schools, then another 2-3 hours in the tuition classes. That is not the case when it comes to other countries. So they either they go to tuition classes or they go to schools, because their education is not double faced, right? Double faced education. So if your school is really good, why do you going for the tuitions? If the tuition is really good, why do you go to schools? So that was the question I had, but I never got a proper answer from my parents. So therefore I had to do both. I had to do both because I never wanted to put them into unnecessary pressure from the society. But I asked that question over and over. Why do we have to do the same thing twice? So why don't we just do one, pick the correct thing and do it only once, just like the students all over the world. So Sri Lanka is a funny country. Sri Lanka is a bankrupt, stupid country. So we do all the stupid things and we think that Sri Lanka is the best country in the world. This is the stupidest, right? The most stupid country in the world. So therefore, my task is make sure you spend very little time in the class, just 2 hours in the session, because I want you spend more times enjoying your life. Okay, so therefore, let's see whether we have covered how many things. Right. So today we discuss about the life cycle of data, data creation, management, removal of obsolete data. Now you know what is data, information, definition of information. You must be having the world's best definition, characteristic of valuable information, right? So need to handle large volumes of data, different complexities like structured, semi-structured, unstructured, right? So the need of managing big data, right? So we have that, right? Applications of information, day-to-day life, official things, right? Decision making. So those things we covered last time, right? Right? So drawbacks of manual information systems, we discussed, very inefficient. Okay. Let me delete this. And corruption, right? Possible errors. So that is why we want to go for computer-based information system. We discussed those things, right? Inconsistencies. Right? So we have done these things. Okay. So emerge of ICT era we discussed, right? So from that is the one we did in the very first day, in the very first slide, right? From Stone Age to the agricultural era to the industrial era, and now we are in the information era. Right? Usages of information in various domains, right? So weather, business, education, right? So we have not discussed these things because those things will be discussed under evolution of computer. Okay, so therefore we have not covered these subtopics. Of course, we discussed the abstract model of information, input, process, output, and also we discussed the importance of feedback, right? When it comes to computer-based information system. Now we have done. Still, we have not discussed, of course, we discussed the CBIS component, but not into great details because we are going to cover those things in our second topic. So therefore, let's say still we have not done those things. But we discussed, right, need of the human operators, policies and procedures, right, hardware, software, databases, the need of networking, right? So therefore, we have covered this also in a pretty good level. Right. And of course, today we discuss about the steps in data processing, data gathering, validation, right? Processing, different aspects of gathering, different aspects related to validations, presence checks, right? Range checks. Now you can see how much we have done in a single day, right? So that is what is mean by productivity. Of course, we can do it within 3 months, but we do it within two hours. Okay. Manual, semi-automated, automated, we have done up to this point. Okay, we have done up to this point. Some of these things also we have done, but some of these things we have not done, right? So of course, this is the fully automated, right? I didn't discuss the specific technologies because these technologies we cover in the computer system, right? Introduction to computer. Okay. So batch versus real time. Storage, local versus remote, right? And so on. Right. So we have come up to 1.5. Right. So remember, so we have few more topic, 1.6 and 1.7, then topic 1 is over. Right. So then we move on to actually what we do is before moving to these things, we move on to in the next class, we move on to the second topic. That is what introduction to computer, history of computing, how the computer has evolved, what are the major component of computer, the hardware, software, what is the difference between system software, application software, what is firmware, what is von Neumann architecture of computers, and also we'll discuss how the computer has evolved to the current things, and then we'll look at, right, so this is von Neumann architecture, right? So then we'll look at what the CPU is doing, what the hard disk is doing, what the RAM is doing, what the ROM is doing, what are the buses, okay? Right. The fetch, decode, execute cycle, and so on. So that is your second topic. Right. So how many topics you have? So of course, still we are, now we have done about 50% or more than 50% of your topic 1, okay? Done means done. Okay. So you have only 12 topics, right? So in another 4-5 weeks, we'll say topic 1 and 2 is done. Okay, still not, right? Now your task is go to the Google Classroom, right? So you also have a, now I told you I have a, right, task. I have a responsibility. At the same time, you have a responsibility. My responsibility is teaching. Your responsibility is learning and validating whether you have learned it properly. And then go to the exams and show that, yes, I have done it properly. That means show your colors, get the results. Okay. So therefore, now your task is again go through the note, think about it. Maybe you can prepare another small note or mind map. And at the same time, this is very important. You go to the quiz. Under concept of ICT topic number 1, do the quiz. So no one is going to evaluate and look at your marks. Of course, you can log out and do it also. Then no one can identify whether you or anyone else. So do these quizzes. Once you submit it, there's a link, right, showing view score. So then you can see, of course, it is 0 out of 14 because I didn't mark any of the answers. So today, now because we have finished that topic, now, right, after the session, take another 5 minutes, just 5 minutes, and answer these questions and check what is your marks. If you get 14 out of 14, super, you are on track. But if you get at least 10 out of 14, right, so you are on track for A. Okay, on track for A. Okay, so do those things. So you have to do your task. I will do my task, right? Remember, I don't remember I told you I don't want to look at today's cricket match because these guys are, right? So these are not cricketers, these are just garbage. Right? So I don't want that to happen to you guys. So I want good results. So I'm an engineer, right? So we got the best results, right? So we don't want to see third class things. We need to see the first class things. Okay. So therefore, you do your task, I will do my task, and together we can get the best. Okay. Right. So we stop at this point. Right. Thank you.